Hello everyone, welcome back. So far we saw several cases, several scenarios of partial fraction decomposition, right? So let's do like 5-6 problems from all the cases and compare them all together, okay? So before we move on to the next step, we have a good idea about partial fraction decomposition. Let's get started. So here's the first example. So no matter what case you have, what is the first thing you should do? Factor the denominator as much as possible. So x square minus x minus 12. So numerator, keep the numerator. If you factor the denominator, you would get x minus 4, x plus 3. Okay, now you should know how to factor a quadratic polynomial by now. Okay, all right, so now we have distinct linear factors. So two different factors and they are linear. So the decomposition is easy. So a over x minus 4 plus b over x plus 3. That's it. Okay, easiest case. Perfect. Let me give you the second example. So 3 over x plus 4 square, x minus 7, x plus 8. Alright, so this is already factored for you. Now we have three distinct factors, x minus 7, x plus 8 and x plus 4 square, but x plus 4 square is repeated. Okay, now we have a fraction for x minus 7, we have a fraction for x plus 8. Alright, and for x plus 4, so it's repeated 2 times, so count up to 2, 1, 2, so it's c over x plus 4 plus d over x plus 4 square. All right, so that's the decomposition. So we had a repeated factor here. Okay, all right, so third example. The third example is, so this is an interesting one, 3x over x square minus 4. All right, first thing, what should you do? Factor the denominator as much as possible. Now can we factor x square minus 4 furthermore? Absolutely yes. What should we use? Difference of square. So let me show you the trick. Difference of square means, so here you have x square, write 4 as a square. 4 is 2 square. So if you have something like a square minus b square, this can be written as a plus b times a minus b, difference of squares. Okay, that's a trick that you should have in your bag. Now x square minus 2 square can be written as then, so here a is x, b is 2, right? Difference of squares. So a plus b, so x plus 2 and x minus 2. So that is how you factor an expression like a square minus b square. Okay, so here a is x, b is 2. Right, now we have distinct linear factors, right? X plus 2 and x minus 2 are two different things. So it's a over x plus 2 plus b over x minus 2. That's the decomposition. Okay, so difference of squares, a trick that is very handy. All right, the fourth one is x square plus 3x plus 17 over x square plus 9 times x square plus x plus 1. All right, factor this as much as possible. All right, now let's have a discussion. First, let's focus on x square plus 9. Can you factor it furthermore? Well, can we use difference of squares? Well, we can't. Why? Now here, the difference between these two expressions that I circled from blue is that in the first expression, you have subtraction in the middle, right here. But in the expression that we have right now, we have addition. So this is not difference of squares, okay? So x square plus 9, you cannot factor it furthermore, all right? If you want, you have to take the square root of negative 9, or you can use that trick b square minus 4ac. Find what is b square minus 4ac. So here b is 0 because there's no x to the power 1 term. So 0 minus 4 times a is 1, coefficient of x square, c is 9. So 0 minus 4 times 9 is 36, negative 36. So we have a negative number. So if b square minus 4ac is a negative number, you cannot factor it at your level. Okay, I will say at your level. When you move on to higher math classes, you will learn new things, but for now you cannot. So this is an irreducible factor. So x square minus 4 versus x square plus 4. This is reducible, but this is not reducible. This is irreducible. Okay, so similarly x square plus 9 is irreducible. How about x square plus x plus 1? Well, calculate b square minus 4ac. So here b is 1, so 1 square minus 4 times a is 1, c is 1, so 1 minus 4 is negative 3. Again a negative number for b square minus 4ac, so you cannot factor this quadratic expression either. So let's write the decomposition. That's all you can do. You cannot break it up furthermore. So the decomposition is a over, oh wait a minute. So we will have a fraction for x square plus 9. Now this is a second degree factor, right? So this will be ax plus b. Alright, you need to have a first degree polynomial on the numerator. Now the next fraction is x square plus x plus 1. You cannot break it up furthermore into factors, and the numerator will be cx plus d, right? Because on the denominator you have a second degree factor. Perfect. Let's go to the fifth example. Let's see. 3 over x square plus 2x minus 6. Okay, so here we have to factor this furthermore. So we should attempt to factor x square plus 2x minus 6. Let's see whether we can factor this or not. So b is 2, so b square is 4 minus 4 times a is 1, c is negative 6. Okay, so yes, this should be this should be you should be able to factor. You know what, let's make it plus 6, because I want one that we cannot factor. Okay, all right, because we will get ugly numbers if we factor the previous polynomial that I had with the subtraction. Now here b square is 2 square is 4 minus 4 times a is 1, c is 6. Now 4 minus 4 times 6 is 24, so you get negative 20, so it's negative, so you cannot factor x square plus 2x plus 6. Okay, so this is all what we can do. So a fraction for each factor. So here x is a factor. Okay, don't get confused by that. X is a factor. I know it's look weird, but it is a factor. It's a first degree factor. So a over x plus bx plus c over x square plus 2x plus 6, right? Because this is a second degree factor. All right, so what I'm gonna do for the last problem is 2x plus 1, x square plus 1 to the power 3 x plus 7. All right, how about this example? Now x plus 7 should be easy, so it should be a over, let me change color, a over x plus 7. Now how about x square plus 1 to the power 3? Can you factor x square plus 1 furthermore? Is it reducible? No, it's irreducible. You cannot factor x square plus 1 furthermore. So this is a second degree factor, x square plus 1, repeated 3 times, right? So we count up to 3, 1, 2, 3. So the fractions will be x square plus 1. So that's for 1, okay? And x square plus 1 square, that's for 2, plus for 3 x square plus 1 cube. All right, the numerators now. So here this is a second degree factor, so this is bx plus c. This is again a second degree factor. I know there's 2 here and you would think this as fourth degree polynomial, but don't think it like that. This is second degree factor repeated twice. So this should be still second degree, so dx plus e. Here also still this is second degree, so fx plus g. All right, okay, so these are 6 examples from partial fraction decomposition, just the decomposition, just to make sure that you have wrapped your head around these 3 different cases under case 1, right? We still have another case to see, but before we go there, well, in the next video, let's find out how can we evaluate these constants a and b, because you are not done with the decomposition until you find these constants, until you evaluate these constants. Okay, so in the next video we will learn how to evaluate these constants. All right, okay, perfect. Thank you very much. Bye bye.